Welcome to the first video of Math 101. Here we're going to do an arithmetic review. Look at all these wonderful things to look at. Decimals, fractions, percents, negatives, absolute values, exponents and roots, scientific notation, and of course order of operations. Now it is anticipated throughout this course that you are going to have a calculator. Yes, a scientific calculator, not a graphing calculator, though we may show you a few things on a graphing calculator. It is not anticipated that you'll be able to use one, especially on the exams. Since all the calculators are going to be different, you will need to become familiar with yours. And if you have any questions on how to use it with any of these arithmetic functions, let us know. As a reminder, in this video, we're going to have some problems for you to do and to put into your video notebook. There will be a series of problems just at the end to give you a review of these. So you'll be able to fill those out, put them in your notebook so that when you have an interview, later on in the semester, you'll be able to have that filled out. So stick around, watch the video, and then do those problems and put them in your video notebook. All right, let's begin. Let's see what we can remember about some of these things. Decimals. We don't find there's much of a problem when you stick decimals into calculators, so I'm just going to put a check mark by that one. I think we're good on that. Now, on the fractions one, as soon as we do this, it's a little bit different. When you have the fractions going on, first of all, let's remember what a fraction is. Let's take a fraction like 7/8. Do you guys remember how to turn that into a decimal? Well, yes, this fraction bar with a number on the top and a number on the bottom is a divide sign. So this is 7 divided by 8. You stick that into your calculator and it should punch out 0.875. There you go. Okay, that's good. Now, what else happens with fractions? Oh, multiplying them. If we were to take 2/3 times 4/5, multiplication of fractions just goes straight across the top. So it'd be 8/15. Now I'm going to pull up those calculators we saw before. There we go. Notice that right here, this guy has a fraction button, and that guy has a fraction button as well. And you could stick them in using that fraction button. Like 2 fraction 3 would be 2/3, or 5 fraction 4 fraction 7 would be 5 4/7. So that'll help you if you didn't want to do it by hand, and you should learn how your calculator does it. So multiplication of fractions straight across, not a problem. What about division? Do we remember how to divide fractions? 2/3 divided by 4/5. Ooh, this is where we multiply by a reciprocal. 2/3 times 5/4, and that would give you 10/12, which reduces down to 5/6. Some of you may have forgotten this, but 2 and 4 you could simplify ahead of time, and that would be a 1 and a 2. 1 times 5 is 5, 3 times 2 is 6. In a calculator, you can stick it in there and hit enter, and it will reduce the fraction for you. Now, a couple of things with fractions that we should remember, especially when we're doing reciprocals. If we take something like 0 divided by 5, that's going to come out to be a nice number 0. Because remember, 0 divided by 5 equaling 0 is the same as 0 times 5 equals 0. Let's write that up here so we can see that. 30 divided by 6 is 5. That's the same as 5 times 6 equals 30. Yeah, these are the same problem. So 5 times 0 equals 0. Now the one that's bad is this one. Go ahead and punch that in your calculator. People think it's 0, but it's not 0. Your calculator says error, division by 0. Yeah, think about that. 5 divided by 0 equals what? Well, this has got to be the same as whatever we're talking about. Times 0 equals 5. See how this times that has to equal the top guy? Whatever's in here times 0 has to equal 5. There's no such animal. It can't happen. And so it's good to keep in mind that that simply isn't an option at all. We officially call that undefined. Excellent, excellent. Okay, addition, subtraction of fractions. Now again, the calculator will do it, but if you have 2/3 plus 5/3, the denominator is the label for the fraction. It says you've got 2 of those thirds plus 5 of those thirds, give you 7 of those thirds. That's why denominators never add. Now what if you don't have the same denominator, like 2/3 plus 5/6? That's right, you have to change the denominator to get it the same. Times by 2 times by 2. 4/6 plus 5/6 gives you 9/6. Hey, that's going to be 3/2. Now, you can write it like this or 1.5. Both of them are correct. This one is the more acceptable one that we're going to be using in the course as a an improper fraction. All right, fractions done. Now let's move on to percents. Let's see what we remember about percents. If you got 8 out of 9 on a quiz, you punch that into your calculator and you get 0.888. Oh, that goes on forever. Now a percent means that you 2 decimal places over. It comes from the word per, meaning divide, and cent, meaning hundred. So when you move it 2 decimal places over, you have 88 point, and then round there, 9%, meaning if you divided back by 100, 88.9 divided by 100, you would have this exact number. Percents are not numbers in and of themselves. So if I said 57%, okay, that's 0.57, but 57% of what? It's always got to be of something. For example, 10% of $15 is $1.50, but 10% of $200 is $20. You always need to know what this percent is of, and it will always be the original price or value or population. So 57% of, say, 230. How do we do that? This is 0.57. Write it down as the decimal of times 230. And then go ahead and punch that in your calculator. There we have 131.1. There you go, and that's how percents work. Check. Now let's do negatives. All right, let's see what you remember about negatives. Negatives, negative actually means the other direction. So if we take the number 5, and then we put a minus in front of it, it's now -5, which moved it clear over to the other side, like on a number line. Here's 5, here's -5. And what if we move it back? Then that's a -5. Yeah, that's where we get the 2 negatives make a positive. So this right here actually isn't a number. This part is a direction. And that's important to know, that every time you get 2 negatives right next to each other, they switch direction. So if we have like a -2 times a -5 times a -7, -2 times -5 is a 10 with 2 negatives, times 7 would be a 70, but now we have 3 negatives on it. Well, these two right here, no, they make it a positive, so it's overall a -70. Yeah, 1, 2, 3 negatives. Every 2 of them will cancel each other out. But what about with addition? What if we have like -5 minus 7? Notice that if we take the real life interpretation of this, if you lose $5 and then lose 7 more, you've lost a total of 12. These actually added, and it's because the 5 and the 7 were both going in the same direction. If they're going in the same direction, then like a tug-of-war, they're adding. But if you have -5 plus 7, they are opposite of each other, and so they will go, whichever one's bigger will win. Notice the rule of 2 negatives making a positive, or a negative and making a negative and a positive making a negative, don't hold true in addition. Good. So make sure you know how to plug those into your calculator. All right, now we come to absolute value. Absolute value. It turns out that negative numbers like -7, in some parts of speech, this doesn't make any sense at all. Now, we kind of understand what -7 means, don't we? But think about it. Have you ever seen -7 trees in a field, -7 cars in a parking lot? Or even in your bank account, have you seen -$7 bills in your bank account? No, of course not. This, because it's a direction, means it's falling one way or the other. It's colder, or it's on sale, or there's, I don't know, other things that could go negative. Distances never can be negative. If you say, how far is it from the number 5 to the number 8? Well, the distance is 3. What if how far is it from 8 to 5? Well, it's still 3. Whenever you're talking about distance, absolute value, negatives don't make any sense. So mathematicians made up a thing and saying, no. Doesn't matter what we get out, we always want it to be a positive number. And it really came because of the number line. What we just said, if there's the number 5 here and the number 8 there, and I say, what's the distance between those two? You would normally take 8 minus 5. Well, what's the distance going backward? You would then do 5 minus 8. And what they wanted was something that whenever you did this operation, it would come out to be the exact same distance. And so that's where we get absolute value. Just changes everything to a positive number. Just says, hey, the distance between these two is 3, and we're not worried about the direction. And so that's when absolute value gets used. Okay, now on to exponents and roots. Let's see if we remember everything about exponents. 5 to the 3rd power. This is what's called exponential notation. An exponent is a repeated number of multiplications. So this is 5 times 5 times 5. Good. So this is called expanded notation. And then if you take the expanded notation and actually evaluate it, that's where you get a 125. So this is exponential notation. This is expanded. And this is evaluated. Good. Now, what does that look like on a calculator? Well, let's pull up our calculator and show you that. On this one, it has a little caret here, and that's what it does. It says 5 caret 3, and this little guy right here means the 3 is up there, trying to be very specific there. So 5 times 5 times 5, 5 to the third power, 5 cubed is 125. Similar to this, well, you could do several of them. 7 squared is 49. 8 to the third power, that's 512. 6 squared is 36. Opposite of powering something is rooting it. And we use this symbol, square root of 49. Oh, that's a 7. So if you've forgotten those, what it actually comes from is, think of a tree like this. We're going to call it the squaring tree. If you take numbers like 2, 3, 4, 5, you square 2, and it comes up here to a 4. You square 3, and you're up here to a 9. You square 16, square 4, and you get 16. Square 5, and you get 25. It creates this kind of tree up here. And if you want to go back to its square root, that's the idea of the root coming out. So that's how you do it. Square root of 36 is 6. Now, when it's a cube and you want to go backwards, they write it like this. Cube root of 512 would be 8. Make sure you can stick those into your calculator and that you and your calculator understand each other. All right, one of the coolest ones here, scientific notation. See if you remember a little bit about it. If you have something like 2.7 times 10 to the 8th power, every time you multiply something by 10, you add a 0 or move the decimal place 1 to the right. So really, this is 27 with 8 decimal places moving from here. Once passes 7, and then you've got 7 more times to give you that number. Huge. And if you want to suck it back up in, you count the number of decimal places to get it to right there. Now, the reason this is so valuable is you're able to write the number with an exponent over here and a number that's somewhere between 1 and 10 right here. This allows you to write numbers that might be really, really huge but can't fit on your computer screen. Let me show you an example. If I were to say take something like 200 million, I think I got enough there, and times it by 300 million. Oh, didn't quite get what I only times it by 3 million there. Notice what I did here, this calculator, and this is what you need to do with your calculators, find out what is going on. 6E15? What in the world does that mean? Well, we just took 2 times 10 to the 8th times 3 times 10 to the 7th. That's what I ended up timesing in there, and we got a 6. And yeah, this was 200 million. A lot of zeros there, times 3 million, and we got 6, and then there are 15 zeros behind it. Yeah, look at that. This is 6 times 10 to the 15th power. This is how this calculator writes it. Now, the other calculators that you guys may have, like this, notice they have different ways of doing these exponents. This one right here may put the exponent right up here, and the other one will write it like the calculator that I have in front of us. So let's just double check and see how you would input it. If you wanted to put something in to this E is times 10 to the number. So you would push that button right there. Do you see this little EE? And most Texas Instruments will have a similar thing right there. You might have a times 10 with a caret on the bottom, but times 10 to the 8th. Times 3 times 10 to the 7th, and you'll see we'll get the same number. So you've got to take some time with your calculator to make sure you and your calculator understand how it is writing scientific notation and how you can input it so that it can handle all these problems. Because the nice thing about this entire section is you don't actually have to do these problems by hand. You're welcome to use the calculator for as many of them as you possibly can. And the final one, order of operations. Now, many of you have learned something like this, PEMDAS. You have learned some marvelous, wonderful things there, and I don't want to take away anything that you've learned, but this is usually not totally sufficient for students to fully understand order of operations. I'm going to start very basic and then show you what order of operations is, and then we'll talk about these acronyms that you may have learned growing up. So first of all, if I take 2 plus 3 times 5, there are two different options. If you just read it left to right, you get 2 plus 3 is 5 times 5 is 25, or you get 5 times 3 is 15 plus 2 is 17. So you either have a 25 or a 17. There has to be a right answer, and there is. Why do we do multiplication first? I mean, most of you know that, and that's great. Well, let's actually stick it in the calculator and make sure everybody's aware. 3 times 5. The calculator will do it right. This calculator and all the calculators that are scientific or above do know the order of operations. So they get the right answer, 17. Marvelous. So why do we do this first? It's because this is a shortcut. All multiplication is a whole bunch of addition. It's actually 2 plus 5 plus 5 plus 5. That's what this problem actually is, and so it took all of this and shoved it right up into there. It's shorthand, so that's why multiplication always comes before addition. Okay, what about exponents? Why do they come first? Well, the same thing. If I have 2 times 3 to the 5th power, notice that this is really a shortcut for 3 times 3 times 3 times 3 times 3, and it's all shoved into there. So we've got to take care of that exponents, and then we could multiply. So 3 to the 5th, I think this is 243 times 2 would give us 486. Okay, so this is why exponents have to come before multiplication. So I'm going to put levels here, multiplication and then addition. Now, the place where people most often mess up are with division and subtraction. So let's do a couple of those really quick. If I take 5 plus 3 minus 2 plus 7, this is not a difficult problem. People will look at PEMDAS and like, oh shoot, we have to do this addition before this subtraction and all sorts of things. You actually could do this in any order you wanted. 5 plus 3, as long as you kept that as a -2. When you were taught this long ago, you were taught to do these guys left to right. But it really, if you picture -2, the negative on that 2, you could do it in any order you want. Of course, if you made $5 and made $3 and lost $2, then added $7, it shouldn't make any difference which order that comes in. And that's true. So addition and subtraction are really kind of on the same level. You just can't like take this 2 plus 7, make it a 9, make this 5 plus 3 minus 9. That would be bad. So when you were young, they said just do it left to right. But really, you could do this as -2 plus 3 plus 5 plus 7, or 7 minus 2 plus 3 plus 5. You will get the same thing on all of these. So that's that. Multiplication, division. Oh, this is what I wanted to tell you. All subtraction problems, like 7 minus 2, actually can be written as addition problems. And you're like, this is the dumbest thing I've ever seen, right? I remember thinking that. Why would anybody ever write it like that? It's because when everything's addition, you can switch around in different orders as long as you put that negative right on that too. Well, division turns out to be the same way. Do you remember when we were multiplying fractions and we divided something like this? Do you remember how we do this problem? 2/3 times 8/5. Yeah, division actually can be turned into multiplication if you do these reciprocals. Yeah, so that means if I have, say, 40 divided by 5 times 2, some people will forget and they'll say, oh, right. I have to do multiplication before division. Well, when your teacher taught you when you were very young, they said do it left to right, which you'll be safe with. But here, 40 divided by 5 is 8, times 2 is 16. Double check that on your calculator. Make sure I'm not doing something weird. 40 divided by 5 times 2. Yeah, it will just do it left to right, and that's great. The reason that's so important is that this actually, dividing by 5, you could rewrite it as 40 times 1/5 times 2. Then you could do it in any order you wanted. 40 times 2 is 80, times 1/5, or divided by 5 is 16. 2 times 1/5 is 2/5 of 40 would be 16. So it actually, there are different levels. Multiplication and division is more important or higher priority than addition subtraction. But these can go in any order and these can go in any order as long as you put the division of a number as multiplication of a reciprocal, or the negative sign attaches to a number, and so you're always adding. And so really these are the orders. So the parentheses can actually interfere with any of these orders. For example, right down here, if I wanted to say 40 divided by 5 times 2, and I actually wanted you to do the 5 times 2 first, I'd put the parentheses there. The teacher gets to mess up the order of operations, say, no, do multiplication first, or do this addition first. Or if I had 2 plus 3 times 5 squared, normally I do the exponent, and then the times, and then the adding. But I could do that. I could do this multiplication, the adding, and this just means it's all one number. Parentheses aren't really operations. They are called grouping symbols. They just say, hey, wait, all of that is one big thing that we want to the second power. Okay, let's give you an opportunity to do some. We're going to call this To the Boards, where you get to go up virtually to a whiteboard and try some problems on your own and see how you did. To the boards! Okay, here's some problems. Go ahead and try these. Press pause in the video, and then when you are ready to check your answers, go ahead and unpause the video, and we'll see you back here in a minute. All right, welcome back. 5/8 to a decimal is 0.4545 on forever and ever and ever. 2 and 5/8 times 3/4. You can plug these into your calculator, or we have, this would be 6/21 times 3/4 is 63 30-seconds, or it would be 1 and 31 30-seconds. 17 divided by 0, this better give you an undefined. We don't get to divide by 0. 5/8 plus 7/20, we need a common denominator. Turn them both to a 40. So times by 5, times by 5, times by 2, times by 2. We get 25 plus 14 is 39 40ths. Good. Absolute value of 17 just makes it positive. Absolute value of negative 17 just makes it positive. 58% of 249. I'm going to punch that guy in. 0.58 times 249. And that's 144.42. Good. Here we have 1, 2, 3, 4. 4 negatives timesing, which means the answer is going to be 1, 2, 3, 4. Those two will cancel, and those two will cancel. So we've got 3 times 2 times 5 times 4. That's 20 times 6 is 120. -8 minus a -3. Two negatives going right next to each other make a plus. So that's -8 plus 3. The -8 wins, and we get -5. -8 plus a -3. Those are two numbers that are negative that are being added together, so they're both headed in the same direction. We get a -11. 7 to the 4th power. When we punch that in, that's going to be 7 caret 4. Excellent. And that's 2401. When we plug these into our calculator, however your calculator uses it, 3.5 times 10 to the 8th plus 9.1 times 10 to the 7th. And, ooh, there we go. Do you think we could make that scientific notation? Mode. Scientific, right there. Let's see what we get. 4.41 times 10 to the 8th. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Equals 4.41 times 10 to the 8th power. Good. Order of operations problem. Word of caution, do not do this 3 times 2 first. This is 6 divided by 3 is 2 times 2 is a 4. 40 plus 4 is 44 minus 49 is a minus 5. Now you should note that you can do that in your calculator straight across. Plus 6 divided by 3 times 2 minus 7 to the 2nd power. Oh, let's get that off of scientific notation. That was funny. Go back to normal. It put everything in scientific notation. Good. So the number -5. Excellent. And then here we have 1 plus 1 plus 1 times 0. You think it's 0? It's not. This right here is 0. So we have 1 plus 1 plus 1 plus 0 equals a 3. All right. How did you do? Make sure those are in your video notebook, and then you are ready to do your online assignments. Great.